Hello and welcome to 8051 Microcontroller lecture series. In this lecture, we would be learning about programming in Keil microvision 5. This is a simulation software for 8051 programming and definitely has got many advantages over mvision5, which is a basic simulation software for 8051 programming. So before getting started, you need to install the Keil Microvision 5 software from the website of Keil. And after downloading it, you have to install it. And I have already installed this software. Now I am opening it. So this is version 5. And this is the latest version of this software. Basically, the products of ARM uh, basically can be simulated using this software. So let's start by creating one project. So for that, we have to go to project and then new microvision project. So when you click that, so it will ask you to identify a place where you would like to save the project you are creating. So let me create a separate file for it, and I'm just naming it RTY, just any name, and I'm again let me name this project as a timer project. So we will try to simulate one program using timer and in this microvision 5 software. Okay, so I click save here. Okay, now next thing is I have to search for the device that I'm using. So you can select any of the 8051. There are many manufacturing companies, but I am selecting there is a Philips and then Dallas, and there are many, but I am selecting the Atmel. At wait, I'm selecting the microchip product. So I have to select one of the product of the microchip. I'm selecting this 8089C51. So if you click it, it will give you the description of the device. So it's a 8051 based fully static 24 megahertz CMOS controller with 32 IO pins, IO lines, 2 timer controller. These are 16-bit timers, 6 interrupts, 2 priority levels, and there are other details. 4 kilobyte of flash memory, 128 bytes of on-chip RAM. So I'm selecting it, I'm clicking OK. So it's asking to copy to a project folder and add file to project. You have to click no. So now the project has been created. Next step is to click a new file here, and this is the editor on which we would be writing the program. So let me select, just copy paste one program that I have already written in AdSim. This is AdSim, and I have written a program on timer. Basically it is a program which generates a square pulse with uh, a duty ratio of 0.5, and the frequency of the pulses of the pulse is 1 kilohertz. So if I run this program here itself, you could see that basically this pin 2 of port 1 is getting 0 and 1, 0, 1. That means the output at pin 2 of port 1 is generating a waveform, square waveform, but the problem is we can and cannot actually see how exactly that waveform is looking, and that shortcoming will be just removed when we will be using the uh, the microvision product. So I'm just copying this program and pasting it uh, uh, on the editor of the microvision 5. Okay, I have copied it here. Then the next step is to save it. So you save it. It's better to save it, but it's necessary to save it within the folder or ty that you created. You just have to name it. So let me give it the name timer only, and I have to add extension .asm because this is an assembly language program, so I have to write the extension .asm. Please don't forget to add this extension. I'm now saving it. Okay, then the next step is to add this code in the option target. So so you have to right click here and add existing files to group source 1. You click this one, and this is our the program that we need to add to this source file. So I'm adding it. So close. So you can click it and see that this program has been added to this source group 1. Okay, now we are reading with the program, and there are multiple options and multiple things that could be done. Before starting, we have to compile the program once. So I'm clicking this. You can click F7 also on the keyboard, or you have to click this one. So if you click it, you can see, observe here that it is, I'm compiling the program, and finally there is one warning and there is no error. Okay, so we will proceed. uh, we will proceed now. We have to go in debug mode and then start debug. So it's saying that the code size should not exceed 2K. So it's okay, our code is not that long. Okay, so after clicking that, multiple windows will open. Okay, so many of them are not required. Basically, you can just uh, remove them. You can see, but that those windows basically contain the information about the program. So here you could see the various registers and their values here. So when program would be running, so you could observe the register values here. Similarly, A, B, these are special registers called SFRs, and you can find the values here also. Stack pointer, at when you reset it, it points to 07. Then PSW is there. Each of the bit of the PSW can be observed here. Okay, now our intention is basically to see the waveform at the output. So there is analysis window. I'm clicking it. So just bring down a bit lower. So you can see this logic analyzer here. So I'm interested in seeing the output at pin 1.2. So please remember that this program basically generates a square pulse at pin number pin 2 of port 1. Okay, so just quickly see how the program works. So clear means the output is 0 at pin 1.2. Then a call has been called, a delay has been called, and that delay actually is of 500 microsecond or 0.5 milliseconds. And then again, after delay has been completed, then the pin is set to 1, and then again delay is called from 500 microseconds, and then the program repeats. So that's how a square pulse is generated. So we can see uh, the output of pin 1.2 by clicking at this point setup. and adding pin 1.2 here. Okay, so you could see here that the waveform would be in red color. You can change any color you want. Okay, so close. Now pin 1.2 output is being shown here. So now I'm clicking the run button. You could press F5 or a run button which exists here. So if you click it, so you just see square pulse has been generated. Now let me just magnify it. So see, these pulses have been generated. You can zoom in so that it becomes more visible. Okay, so this is the pulse that is being generated at P 1.2. I hope you understood the lecture. There are multiple things that could be done using microvision software, so we will learn them in future videos. Thank you for watching.